something like, it could be anything. How about 13 times 15? Okay. What you can do is you can break 2-digit numbers or 3-digit numbers up. All right. So you could, and by that I mean a fancy math word we could say is decompose. Right. We could decompose 13 into 10 and 3. And we can decompose 15 into 10 and 5. Okay. And then really you could do 10 times 10. Actually, maybe not. Let's fill out the table. I'm just playing around here. I'm going to do it my way, and then we can check after to see if there's some shortcuts, okay? So you guys can play around with this. You can write on your Mathicon sheet, okay? And when we go up, I want to deal with under numbers, okay? There's some number tiles, okay? These are like, if you guys have ever seen the base 10 materials, the things that kids like to build, like they're stackable, and you could get all these different shapes. You guys should have seen these at some point, okay? You can build with them. What you'll see is, let's turn this. In the rods, there should be 10, okay? And the reason why I'm using number tiles instead of these algebra tiles is I want to keep, there's a little bit of like, this is 10 here and this is X, okay? They're different at the moment, okay? So with the number rods, you're going to get 10, and we have 10 twice, right? And then additionally, how do you represent 3? Well, you just represent 3 with 3 little single tiles, okay? So there's 3, okay? And then over here, you're going to represent 5. As 5, okay? All right, so here's what we got. We've taken the numbers 10 and or 13 and 15, and we decomposed them into smaller numbers that we could probably multiply together and like kind of work with easier, right? So what I think is kind of cool, and I'll extend this because I know it's going to be a little bit longer here. Might not be quite that long, but we have like what we call the table method, okay? And what you can do is you can take the decomposed pieces of your numbers and you can put them down the side and across the top, respectively, okay? So we can go like this with the 10 from the 13 can go here. And I'm going to grab my 3s and I'm going to put them down here. Okay? Kind of try and group them maybe. Right? And so what you're going to see here is we have the number 13. There's 13 rods total. There's 10 and 3 in a table. Okay? Then across the top, you can do the same thing, but you have 15, right? So let me just grab this. We'll rotate it. There's 10 there, and then I'm going to grab the 5, rotate it. Okay, and something cool happens once I actually try to fill out this table. I just finished doing the grade 9 applied, and they love doing this table. And it's the reason why I'm showing it to you is because they continue to use it in the remainder of the 20 questions when I gave them that sheet, right? So here's what you got. Okay, I can write on top here too, actually. There's 10 and 5. Okay, so there's your number 15 across the top. And your job, we call this like let's call it like a table method, right? But it's really like an area model, if you will, okay? Everything inside of here, if you guys remember doing areas of like shapes, you always had length and then times width, okay? And then to get the area, you would multiply them together and you would get the area, right? Straightforward enough. You're going to take the exact same idea here, right? This could be your length and this could be your width. And when you multiply them together, you get the area on the inside. I shouldn't have drawn that because I have to erase all this. Oh, maybe that's good. Okay. So that's all we're going to do. We're going to multiply these two things together. But the catch here is you could, let's see how this goes. This works a lot better on my iPad because I can draw straight lines on my iPad. The mouse is kind of tricky. Okay, so we essentially get this table in kind of 4 quadrants, right? We have 4 quadrants because I need to multiply the 10 times the 10. I also need to multiply the 10 times the 5. And then once I've done that, I've hey, no worries, Maddie. It's okay. We're just getting started, okay? And then, then you can do the 3. You got to do the 3 times the 10, so that takes care of this quadrant, and then the 3 times the 5, right? And the area, the total area, is going to be what the total area, sorry, is going to be the total number of little squares that you see inside these 4 quadrants when you add them all together. Okay. Does anybody have any questions so far? Are we okay? Okay, so it turns out, this is what I really, really like about the tiles, or these, not tiles, sorry, the base 10 material. Okay, my eraser's not erasing that. That's good. I think most of us are okay with the fact that 10 times 10 gives us 100. What we had when we worked with base 10 materials, something that had 100 squares. It looked like this. There are 100 squares there. Okay? And then, on top of that here, I'll write 100. There's 100 here, right? 10 times 10 is 100. I'll write how we got there. Okay? Okay? And then, we take 10 and we multiply by 5. And what do we get? Well, it looks like we get 50. We know it's 50, right? 10 times 5 is 50. Why is it 50? Because there's a 1 times a 10 gives me 10. But it happens 5 times. Right? So essentially what you get... Oh, I don't need that many. We'll get rid of one. Okay, essentially what you get is you get 5 of them. Right? You get 5 of these rods because there's 1, 2, 3, 4, 5. Right? So 5 times 10 gives you the 50, right? That's where this comes from. There's 50 blue ones here, right? The exact same thing happens when we go to do the 3 times 10, right? We're going to see, okay, well, we're multiplying these kind of blue rods that are rods of 10 against 3 individual ones. So I should see 3 blue rods spit themselves out here, right? Like this. Two and 3, right? So we know if we were to sit there and count all those up, there'd be 30 of them there, right? There's 30 total. Right? And so we know there's 30 because 3 times 10 equals 30. And then the last one you have to do, so you get each one of these individual ones times one of the individual ones up here, right? So essentially what you're going to get is get 3 times 5, which is going to be 15. Now I could sit here and do this, and this might take a minute. Once I get 5, I'll be able to copy paste. Okay, so there's 5 there. All right, so 3 times 5 gives me 15. Okay, and so we've produced this area. Okay, we have the inside is going to be an area, right? And that's ultimately what we want. That's our answer, is what's the inside area, right? And this actually is the answer to, once you calculate or add up the area, you actually get the answer to 13 times 15. Okay? So, if we add up the area on the inside, we're going to get 100 plus 50. Oh boy, what's going on here? I promise this will go easier on my iPad when we actually start doing questions. Plus 30 plus 15. And the answer, and I know you guys could type this into your calculator, obviously, right? I get that, right? You might be sitting there right now, this is ridiculous. I'm not doing this because I can type it into my calculator. You'd be missing the point of what I'm trying to illustrate to you, okay? I'm going to use this concept to teach you how to do the last 20 questions on that sheet, okay? I just wanted you to see it actually working in front of your eyes in something that you know how to do. 13 times 15, you could type it in your calculator and get an answer. I want to show you the behind the curtains of what your calculator is actually doing, right? So that when we come down and they're not numbers anymore, like what you see in number 20 onwards, that you can just apply this process and figure it out, okay? So the answer should be, when I add this up, 0, 0, 0, 0, 0, 0, 0 plus 5 should be 5. 5 plus 3 plus 1 should be 9. And the 1, 0, 0, 0 should be 195. Okay? Does anybody have any questions? 195 is how many squares you see here when I were to add these all up. Okay? Now, we could sit here and do this all day. You could also do it for, like, the tables can get infinitely big. You could do something like 121 times, I don't know, 24. You could do that, no problem. You would just break everything down. This one would have 3 pieces instead. You'd have 100, 20, and 1. And then this one here would be 20 and 4. And you would make a table accordingly, right? You'd go like this. Across the top, you might choose to put the, sorry guys, this is a mess. 100, 20, and 1. And then down the side, you might put the 20 and the 4. And you would fill in the area, which would be all of this, with multiplication. So you do 20 times 100. Well, that's 2 times 1 with 3 zeros. 1, 2, 3. And 20 times 20, well, 2 times 2 is 4 with 2 zeros. So 400. And 20 times 1 would be 20, obviously. 4 times 100 would be 4 times 1 with 2 zeros, so 400. And 4 times 20 would be 4 times 2 with a 0, so 80. And then 4 times 1 is 4. Okay, and you could add all these up, you would get an answer, right? It's 2,000 plus, so 2,800, 2,880, 2,900, and so 2,904, if I'm not mistaken. Let's check that for sure. I may have added it up wrong. Let's see. You guys can check it too, right? It's up to you. Hey, I'm good. Okay? Anyway, I think this is really cool. I'd never seen this before. And then to put it in the bigger picture, because now I have the bigger picture. You don't, but I'm going to teach you the bigger picture. It's kind of cool to see its application in something different. Okay? what do I want to do? I want to stop it here, I think. And then I'm going to move over to my iPad. No, not yet. One more, okay? So my question now becomes, what if we're not dealing with numbers anymore? What if I switch it back to algebra tiles here for a sec, okay? It's the same table. I'm going to put a table down. But this time, what if my question is not numbers anymore? It's, let me just draw a line. Let's just say I'm doing something like, I don't know, 3 times, let's make it more difficult. 2x plus 5, for instance. Okay? What just happened? Hey. Okay? So, this looks like I have an area model here, right? I have some, I have a length, and I'm multiplying that length by a width. Okay? So why don't we just take what our width is and put it up top? And I can remember, I should be doing this. We can represent these things using tiles. Well, what does 2x look like? 2x looks like,
If I was to like start that question randomly, how would I figure out what the width is aside from the length?
it doesn't matter. So you're talking about this one specifically, Zach?
Yeah, like how would you know which one's the width and which one's the length?
So the thing is, like, it doesn't actually matter for the reasoning that, like, if I were to do 6 times 8, right?
Yeah.
8 times 6 both yield the same answer.
Yeah, but like there looks, say if there was like no brackets and there was 3 plus 2x minus 5 whatever, how would you know which one was, like, if there's 3 things, how would you know which one's the length?
Oh, you mean like if there's a plus sign here instead?
Yeah.
Okay, so if there's no brackets, there is no area model. It's not like the area model only applies if you see brackets. So in this particular question, there would be no length and width. You would just collect the like terms that you saw.
Oh, so that's just a different way of answering that type of question up top.
Yeah, this is basically, Zach, what you want to do is turn something that looks like this into this so that you can do the work from this morning. That's what we're doing.
Oh, okay.
Okay,
Right.
we're almost there. Almost there, buddy. That's good. It's like good for, like, that's where we're headed, right?
Right.
So this little table allows us to do that. Okay, you're gonna see it's gonna spit something out, right? The order does not matter. It doesn't matter where you put what, because multiplication is interchangeable. Okay, so we can put, what I'm going to do here is I'm going to use the tiles just because I think the tiles actually help. Okay, and so here's what I'm going to do. I'm going to have 2 x's, right, because that's what it's telling me to do. And I'll multiply those 2 x's, or sorry, we'll get one more piece here. I'm going to add the 5s in, okay? A. You can click on it. You guys know that? You can click on them and they add up faster. Didn't know that. Okay, so you got 2x plus 5. That's this expression right there, okay? And what I want to do is multiply that by 3, right? And basically what we're going to do, we're going to fill in the table. I might even space these a little bit. And keep in mind, this is the first time I'm doing this, guys, so just bear with me, okay? It becomes easier when you don't have to, like, when we get to the point that we don't have to build it with tiles anymore, the whole thing just becomes a little bit easier, okay? But anyway, here's what we got. I'm going to stack it like this instead. Sorry, guys, okay? And then I'm going to draw a table. Okay. Okay. Now, oh, I don't know why I have an extra line there. Okay, so this is telling me here, I'm going to have 1 multiplied by an x. Well, if I multiply anything by 1, it's just itself. Okay, and so I got an x there. And basically what you're going to see is you're going to see this happen 6 times, right? Each one of these, 1 times an x is an x. And you're just going to do it every time, right? Okay, so I've built a good chunk of my area model. Keep in mind, like, the area is all going to be inside of here, right? I should have used a different color. Okay, and essentially what's going to happen, I'm not going to do this, but 1 times a 1 is going to give you 1 of these. And how many times are you going to do it? You're going to do it 15 times, right? Because you're going to have to do 1 times the other one. And 1 times this one. And so on and so forth until you get to, like, there's the top one, 1 time all of these, right? And then you do it again for the next one. This 1 times all of these ones. And then again, down on the bottom, you're going to get this 1 times all of these ones. Okay? And then you're essentially, after you have this done, you just add up the inside of the area, just like last time. Just as if it was numbers. We just added this up and we got this number. Except this time, again, like this morning, we cannot add x's and little 1 squares together. So you can only add the things that are the same, right? So what you're going to get, if I were to group this, you get the 6 x's that are there, and then plus 15, right? All you're doing is counting up what looks like 6x plus 15. Okay? Now, do I expect you to show the table every single time? No. Okay? If you guys would like, this is like physically, if you were to build this thing, this is what would happen. And if you need to do this 2 or 3 times, do it. Okay? But if I were just to, let's forget, like, the tiles are still a thing, right? But let's just say I redid this question and I said 3 times 2x plus 5. Well, you don't have to build this with tiles. You guys can go like this. 3, 2x plus 5, and draw the table. 3 times 2 with an x on it is 6x. 3 times 5 is positive 15. And all of a sudden, there's your answer. 6x plus 15. Right? So we'll go one step further here. Let's suppose for a second that I made this question harder, like what you're going to see in some of these like later questions in number 20. And I decide to add on not a 20. I don't want to add a 20. Let's see if it's even 7. All right. So you're going to do this work here, this length and width model. You're going to do that. And then you're going to write down, basically what happens is the inside, the area, replaces this box. And you get 6x plus 15. But then you can't forget about the rest of the question that's sitting there. plus 7. Right? Well, you can't add 6x's, right? Remember what this is. I cannot add these to this, right? There'd be 15 of these, right? Like what we saw here. But I can add the 15s and the 7 together, right? Because these are both, we call them like terms, right? They'd both be the little squares. They're not the rods, right? So you could clean this up by saying, okay, well, there'd be 15 of these things here and 7 of these. I can clean those up and group them together, right? And your final answer here would be, or fully simplified as it's going to put it in your sheets, 6x plus 22. I had to think about that one for a sec. Where did the 22 come from? That's where you added these two things together. And this would be your final answer. Does anybody have any questions? What I'm going to do is I'm going to jump over to my iPad and we're going to do a couple questions together, harder ones, so that you guys are good to go. Okay? And then that'll be it for the weekends, okay? So I'll hit stop there. I'll upload